Well, so okay, so you're doing you're running this large network. It's a CDN, but it's much more than that because you have compute hanging off of it. Um, is this built like an edge? Everybody's talking about the edge, right? So is this built like an edge network, or is it still largely consolidated into a smaller number of data centers, or what does the actual architecture look like?
It
That's part
originally,
one of the question, and then after you answer it, I'll let you know part two.
so originally, like 15 years ago when we started building out the network, yes, you start out somewhere, right? So you start out with a concentration
Yeah,
in
of course.
Europe,
Yeah,
US, and one in Asia. But nowadays, in order to serve all those very demanding gamers and all those voice and video
yeah,
users as close as possible, it's definitely an edge network. All the 60 locations. There's a few bigger than the others, as always. You cannot avoid that.
yeah.
But also, we want to make sure that all of them have sufficient capacity to serve the needs, and also that if one location would, for any reason, fail, natural disaster, whatever, that's the impact or the blast radius is sufficiently minimized because there's so many other locations in the region.
Mm-hmm.
Um, I believe that that's definitely the way forward. But what you also need, well, not in all use cases, like if it's a one directional CDN, so if you're just watching video but there's nothing interactiveness, it's fine. But if there's interactivity or you're in a shared room with users together, watching the stream and talking and everything,
Mm-hmm.
then the connections between all of those edges to each other also starts to matter, because then you're having traffic that goes from one location to another location, and yeah, if you have no insight over it, it goes via third party. You have no control. There can be so many things going wrong. So
Yeah.
that's what differentiates our network a little bit more compared to a general CDN based network which is only focused on one directional traffic. Yeah.
Yeah. Yeah. And I think, that's also another interesting thing about what you bring to market. This stands out in my mind, at least, is that as if cloud gaming is not hard enough, you're powering this ultra low latency gaming experience, which I guess you could say that's kind of the ultimate test of interactivity, right? Because when I move my controller, it better move on screen, and not be laggy.
Exactly, and also all the gamers know to find social media, the pitchforks.
Yeah,
A lot of them are tech savvy enough to do a trace route, so it's not just at a
yeah,
publisher or a client. No, they find us,
yeah,
message me on LinkedIn. It goes pretty far. So,
yeah,
um, but it also always allows us to get better, which is
yeah,
what I
yeah.
really like. But for demanding
Yeah.
users, it always helps to get you to the next level.
But
Yeah.
on top of that gameplay, though, you also have a gamer who then is, posting on social media or live streaming to
Yeah.
Twitch or, whatever. I mean, in other words, not only do you have to keep that game session running
But
and,
also the
and
stream, his monetization.
yeah,
Yeah,
exactly.
yeah.
Exactly. So, wow, there's a lot going on. Well, part two of my question is this. Um, how then are you guys thinking about video encoding and video processing now that you have an edge network? Because it opens up a lot of really interesting possibilities. So, how have you built or how are you building your video solution
Yes.
given the fact that you have these, it's more than 60
Yeah.
pods, right? Yeah.
So for us, both the GPU and also the VPU offering really enables us to make our edge offering more compelling, right? So
Yeah.
being able to offer that close to all of the end users, and if
Mhm.
you have an application which can benefit from a VPU, it's a no-brainer to do it. Um, of course, just because of GPUs, not all workloads will fit in the GPU, just like the VPU, but
Mhm.
if you have one which makes sense, it's a no-brainer. And
Mhm.
what we're now also looking into with my team of solution architects is both GPU on demand and VPUs on demand. So you can rent flexible capacity, and when needed, you add a GPU over IP, for example, or even a VPU over IP to have that ultimate flexibility and also control of your cost and resource. Because the most expensive components of compute nowadays is, of course, that graphical or additional
Yeah.
GPU component.
Yeah.
And if we can enable ways for users to use it more efficiently, that widens the gap with, of course, the competition.
Absolutely.
Yeah.
So in the data center, are you using some sort of a composable technology that would allow you, to have sort of a virtual PCIe
Yeah, I mean there's some ways
connection?
that we're playing with it
Yeah.
on the GPU side of things. There are
Yeah.
some more mature solutions nowadays,
Yeah. Yeah.
but we see the same for the GPU over IP. It might not be the ideal solution if you want to do game streaming. I mean that just benefits from having that card right into the box.
Yeah,
But,
exactly.
but for AI inferencing query loads, or if you just need to pass that check that you have a GPU for your build processes, for your build pipelines,
Mm-hmm.
I believe it makes a lot of sense. And similar for VPU workloads, I think there are definitely workloads where it would make a lot of sense to use it like this as well.
Yeah.
And I think in the next coming years, we will see more and more dedicated component cards, as I like to tell them, which are hyper focused in specific tasks that
Yeah.
might benefit your application. Yeah.
Yeah. Yeah. Amazing.